Here we have the infamous cube question. We take a bit of copper, we put it in acid, it dissolves, and it gives off H2 gas. We know how much H2 gas is generated. We've measured it, and we're going to relate the volume of that H2 gas to the mass of the copper that reacted using this balanced chemical equation. The initial mass of copper minus the mass of the copper that's reacted is going to give us the mass of copper that remains, and this is where we're trying to get to. We're trying to get the mass of copper remaining, so we need to find a way to calculate the initial mass of copper and the amount that reacted. We've already mentioned that we can get our mass of copper reacted by relating it to the H2 gas. And we're going to get the initial mass of copper from the measurement of the copper cube used to get volume, and then we can multiply that by the density of copper. Okay, again, quick summary. We're going to determine the initial mass of copper. We're going to also determine the mass of the copper that reacts, and when we subtract, we're going to get the mass of copper that remains. All right, so here's the calculation for the initial mass of copper. The volume of a cube is length times width times height. So each side is 1.750 centimeters. So if we multiply all of these values together, we're going to get the volume of a cube. Then we look up the density of copper on our equation sheet, put that in here, multiply all these out, and we're going to get the initial mass of copper. Next, we want to get the mass of copper reacted by relating the volume of H2 gas to copper through this balanced chemical equation. Now we know whenever we can compare a chemical to another, it has to be done mole to mole. We're going to use 22.414 liters is equivalent to a mole of a gas. So if we multiply the volume of H2 in liters by the moles per liter, we now know how many moles of H2 we have. Okay, and a quick reminder that this value is on the equation sheet. So we use our balanced equation now. We can relate 1 mole of hydrogen is released for every mole of copper. So we have knowledge of how much copper we had at the start. We know how much reacted, so now we can determine how much copper remains. So here's our last step. We have our initial moles, and we're going to subtract the moles that reacted, and we have the final moles of copper that remain.